designed to immediately capture their attention with a stunning visual and a mind-bending question that sets up the incredible properties of aerogel. We'll open with a close-up shot of a delicate, ethereal-looking substance, almost like a piece of frozen smoke resting gently on a flower. The visual contrast between its ghostly appearance and the fragile petals it sits upon will be striking. A voiceover will begin, speaking in a tone of wonder and intrigue, pulling the viewer into the mystery of this extraordinary material. Imagine holding a cloud in your hand. Not a fluffy, water vapor-filled formation drifting in the sky, but a solid object you can touch. That weighs almost nothing, and yet possesses powers that seem to belong in a science fiction movie. What if I told you this material, this wisp of solid smoke, is one of the most incredible substances ever created by humanity? It's a material that is 99.8% empty space, making it the lightest solid on Earth. Yet, despite its ghostly appearance and feather-light weight, it has the strength to support thousands of times its own mass. This isn't a prop from a Hollywood blockbuster or a figment of a futurist's imagination. This is aerogel, and it's rewriting the rules of what a solid material can be and do. It's a paradox in physical form, an enigma of engineering that holds the key to revolutionizing everything from space exploration to the very clothes we wear. Prepare to have your understanding of the physical world completely shattered as we delve into the secrets of the lightest solid ever made. Aerogel is a material that truly defies our everyday intuition. When you first encounter it, your brain struggles to categorize what it's seeing. It looks ethereal, almost unreal, like a holographic projection or a glitch in reality. Its common nickname, frozen smoke, is perhaps the most fitting description, capturing its translucent, bluish hue that seems to scatter light in an otherworldly way. But this is no smoke, and it's not frozen. It is a solid, through and through, albeit a very, very strange one. The secret to its incredible properties lies in its unique internal structure. At its core, aerogel is what's known as a nanoporous solid. Imagine taking a gel, like gelatin, and carefully, painstakingly, replacing all the liquid within its structure with gas, without causing the delicate solid framework to collapse. The result is an intricate three-dimensional lattice of interconnected nanostructures. A solid mesh that is almost entirely composed of air. This structure, which is more than 99.8% air, is what makes aerogel the least dense solid material in existence. A cubic inch of aerogel can weigh as little as 0.0011 grams, making it just 3 times heavier than the same volume of air. To put that into perspective, if you were to hold a piece of it the size of an adult person, it would weigh less than a pound. It's so light that it can rest on a soap bubble without bursting it, or on the petals of a flower without causing them to bend. This near weightlessness is its most famous characteristic, the one that instantly grabs headlines and sparks the imagination. However, to focus solely on its lightness would be to miss the most astounding part of the story. Hidden within that ghostly, air-filled structure is a level of strength that is completely counterintuitive. When we think of strength, we picture things that are dense, heavy, and solid, like steel or concrete. Aerogel turns this concept on its head. Pound for pound, or more accurately, gram for gram. Certain types of aerogel are stronger than steel. This isn't a misstatement. The secret lies in its dendritic or tree-like microstructure. The highly cross-linked network of nanoparticles, though infinitesimally fine, distributes any applied force or stress across its entire framework. This means that a small, seemingly fragile piece of aerogel, weighing only a few grams, can support the weight of a brick or other object's thousands of times its own mass without being crushed. It's a classic case of the whole being far, far greater than the sum of its parts. The combination of being almost as light as air, yet possessing this remarkable compressive strength, is what makes aerogel not just a scientific curiosity, but a material of immense practical importance for the future. The journey of aerogel from a laboratory oddity to a cornerstone of advanced engineering is a fascinating one, and nowhere are its unique properties more valued than in the unforgiving environment of space. For organizations like NASA, every single gram launched into orbit comes at an astronomical cost. The need for materials that are both incredibly lightweight and highly functional is paramount. Aerogel, with its paradoxical combination of low density and high performance, was a perfect candidate. Its first major role in space exploration wasn't related to its strength, but to another of its superpowers: its incredible ability as a thermal insulator, because it is mostly composed of trapped air molecules within its tortuous nanopores. Heat has an incredibly difficult time traveling through it. This makes it one of the most effective insulating materials ever known. This property was famously put to the test on NASA's Mars rovers Spirit and Opportunity. The delicate electronics that power these robotic explorers needed to be protected from the extreme temperature swings on the Martian surface, where temperatures can plummet to well below -100 degrees Celsius during the night. Wrapping the sensitive components in a blanket of aerogel provided a lightweight, highly effective thermal shield, keeping the electronics within their operational temperature range and enabling the rovers to survive and function far beyond their initially planned missions. But its use in space doesn't stop at insulation. NASA's Stardust mission used aerogel in a completely different but equally ingenious way. The goal was to capture particles from the tail of a comet, tiny grains of cosmic dust traveling at hypersonic speeds without destroying them. A conventional solid would have vaporized these delicate particles on impact. Aerogel, however, acted like a cosmic baseball mitt. The high-speed particles plunged into the soft, low-density material, creating carrot-shaped tracks as they slowed down gently, and were captured intact, allowing scientists to study pristine material from the origins of our solar system for the first time. Looking ahead, aerogel is poised to become even more critical for humanity's future in space. As we plan for long-duration missions to the Moon and Mars, the need for lightweight, high-performance construction materials is more urgent than ever. Future habitats, whether they are inflatable structures or 3D printed shelters, will need to provide a safe and stable environment, protecting astronauts from extreme temperatures and radiation. Aerogel is a leading candidate for the insulation of these habitats. Its ability to provide superior thermal protection with minimal mass and volume is a game-changer for mission architects. Imagine lunar bases with walls lined with translucent aerogel panels, allowing natural light to filter in while providing insulation far superior to traditional materials. It could be integrated into spacesuits, creating garments that are lighter, more flexible, and offer better protection from the vacuum of space. From capturing stardust to building cities on other worlds, Aragel's journey in space is just beginning. While its applications in the vacuum of space are spectacular, the true revolution of aerogel might happen right here on Earth, driven by its most impressive and visually dramatic property, its phenomenal resistance to extreme heat. An aerogel's ability to insulate is not just for the cold. It is equally, if not more, effective at blocking heat. The same nanoporous structure that traps cold air also prevents the transfer of thermal energy. A layer of aerogel, only a few inches thick, can protect a human hand from the direct flame of a blowtorch. You can place a block of it on a pile of crayons and heat the top with a torch until it glows red hot, and the crayons underneath will remain completely unmelted. This demonstration, often seen in science videos, is not a trick. It's a raw display of aerogel's power as a thermal barrier. This resistance to heat, combined with its near weightlessness, opens up a world of possibilities. Think of firefighters wearing suits lined with aerogel, offering unprecedented protection from infernos while being significantly lighter and less cumbersome than current gear, allowing for greater mobility and endurance. In industrial settings, pipes carrying superheated steam or cryogenic liquids could be insulated with aerogel, drastically reducing energy loss and improving safety. The applications in construction are perhaps the most transformative. Imagine windows made of aerogel. They would be translucent, letting in natural light, but would provide a level of insulation that could slash a building's heating and cooling costs to a fraction of what they are today. Integrating aerogel into building materials like drywall or insulation panels could lead to ultra-efficient homes and offices, reducing our global energy consumption and carbon footprint. The potential extends to our everyday lives. It could be used to create the ultimate thermal flask, keeping your coffee hot for days, or a cooler that keeps ice frozen for weeks without any power. Clothing designers are experimenting with incorporating aerogel into jackets and boots, creating winter wear that provides incredible warmth without the bulk and weight of traditional down or synthetic fills. A paper-thin aerogel-lined jacket could keep you warm in the harshest Arctic conditions. The material that protects spacecraft from the cold of deep space and the heat of atmospheric re-entry is on the verge of changing how we build our cities, protect our first responders, and even how we dress for a walk on a cold day. Aerogirl is not just a material, it is a platform for innovation, a substance that is almost nothing, yet promises to change almost everything. The future it enables is not one of fantasy, but one that is being engineered, molecule by molecule, in labs around the world today.